Okay, projectile motion. This is usually the first big hurdle that blows everybody's mind. Okay, one thing. Before you've done this, make sure you go onto Canvas and you complete the first discussion, which says which object hits ground first, and then watch the video and share after you've watched the video, share what you've watched on the discussion. With that being said, let's do this page. Everybody gets confused with this page because maybe it's a little confusing. Who knows? So this is the breakdown of this page, okay? We have a dude dropping a ball, and we have a cannon firing a ball. They both start the same distance from the ground, the same y distance, right? We are going to mark each second where the projectile will be, whether it's this ball or this cannonball. Each second we're going to mark it. So as with every problem we do, we start with the formula. And usually anytime somebody asks for help, I'm like, hey, where's your formula? If the answer is I didn't write it, where's your formula chart? So let's write it. So it's displacement equals our velocity, usually our initial velocity, times our time, in parentheses, plus 1/2 acceleration times time squared. Right? There's our formula. Now, acceleration is going to depend on which kind of displacement we're doing. So we're going to write this two ways. We're going to rewrite it. The first is if we're trying to find the displacement of x. Displacement of x, the initial velocity is just the initial velocity. It is shot. So for instance, x is your left to right, right? So the displacement of x will be, it was shot from a cannon at 20 meters per second. So that's our displacement of x. So that would go here in this x, right? Times your time. How long has it been since it got shot? Plus 1/2, same thing. There's no acceleration if it's shot at 20 meters per second. Unless they specifically say it accelerated laterally, like horizontally. In that case, this is going to be 0. So that your acceleration of x will actually be 0, in parentheses that, times your time squared. Now what does that mean when this acceleration is 0? That means that this whole side is 1/2 times 0 times time, whatever that is, squared. It's going to be 0. It's going to be gone, right? Now your other displacement is the displacement of y. So in that case, it's your up and down. Equals your initial velocity. Well, guess what? When you're dropping it or something like that, your initial velocity is going to be 0, right? Because it's in the dude's hand. So this is always going to be 0 times time plus 1/2. What's acceleration when you drop an object? Well, isn't that just gravity, right? Which is 9.8. You're going to have this memorized before the course is over. Times time squared. I know we're kind of running out of room here. So same formula. Initial velocity times, which is 0 times time, that's gone. You just use a different part of it. Unless they give you the information, you assume certain aspects are 0. So, I know that's probably confusing. That's okay. Let's start working it out. So we are going to do the displacement of y, which is the up and down. So we're going to say, I'm going to cut this part out altogether. Displacement of y equals 1/2 times 9.8, because that's the acceleration of gravity, right? Times time squared. So in 1 second, it's 1/2 times 9.8 times 1 squared. 1 squared is just 1, right? So really it's just 1/2 times 9.8, which is, calculate, 4.9. So in 1 second, the projectile will have fallen 4.9 meters. Which means it's going to be down just a tiny bit. So if we say half of this is 10, doesn't that make sense since it's 20? And we say it's going to be slightly less than half, so let's say about right here. And mine might be a little bit off from yours, but that's right here. Now this cannon has fired. So hopefully you guys have already watched this video. Your y motion and your x motion are independent of one another. In other words, it doesn't matter how fast it's fired sideways. Whether it's a rocket or a gun or a slingshot, it's going to accelerate downward at the same rate, whether it's fired from a cannon or dropped from a hand. So these will be the same at 1 second. So at 1 second, this will be at 4.9. You don't need to label yours, but I'm labeling it. Now at 1 second, this will also be at 4.9. Now before I sketch it in, let's find the x position, right? So the x is just the displacement of x equals the initial velocity. What's the initial velocity? 20 meters per second. Times at 1 second, or times 1, right? Well, that's easy. That's just 20 times 1. So it's going to be 20 meters out, and it's going to be 4.9 meters down. So we'll say about right here. Really, they should be the exact same. So if you want to line them up with a ruler, that's great. Now, let's do the next second. So the baseball y displacement is 4.9. Okay? That's 0 seconds. At 0, it's 0. 0, 0. At 1 second, it's 4.9. Okay? At 1 second, the cannonball's x distance is 20, and the cannonball's y distance is 4.9. Hopefully it's making sense. If it doesn't, just go with it. It's fine. Remember, they fall at the same rate. Let's look at second number 2, the y displacement. So y displacement equals 1/2 times the acceleration of gravity, which is 9.8, times time. Well, since we're second number 2, isn't that 2? And then squared. 2 squared is 4, so it's 4 times 9.8 times 1/2. We know this is 4.9. So 4.9 times 4 is 19.6, which in that case is going to be about here, I'll say. Maybe yours is a little different. 19.6. 19.6. So it's fallen at second 2, 19.6. Cannonball's the exact same. So all I'm going to do is the x distance at second 2. Well, this is not a very difficult formula. It was fired at 20 meters per second initial velocity times 2 seconds, right? Because it's times time. So that's 40. So it's going to be here. It's going to be at 19.6 right here. Notice one is moving to the right each second, but they are both falling at the same rate. That's the whole point of this problem, illustration, whatever. Things fall at the same rate because gravity is equal across every object. If I dropped a bowling ball and I dropped even a feather, right? If there was no air resistance to interfere, in other words, it was a complete vacuum, the feather and the bowling ball would drop and hit the ground at the exact same time. Sometimes I understand that's hard to believe because you always see feather kind of floating around, but that's because there's air. If you can watch YouTube videos of a complete vacuum, you will see that they hit the ground at the same time. Okay, so cool stuff. So hopefully you're getting the point of this. I'm just going to keep rolling with it. So let's do second 3. The y, up and down. Displacement of y equals 1/2 times 9.8 times 3 squared, because we're at the third second. 3 squared is 9, right? So 1/2 times 9.8 times 3 squared. Use your calculator. You should have gotten 44.1. Fact check me, just in case. So 44.1, I'm going to say this is 50, so we're going to say maybe here. 44.1. 44.1. I didn't mean to make this negative. I was trying to make a dash. I see it looks negative, so that's not a negative, right? Let's grab it out. This one will be the same. 19.6. And then second, what did I say? 3, 44.1. I'm not going to do the x one because it should be the same. 40, 60, 80, 100. Right? Consistent. Both of these ignore air resistance, by the way. So just keep that in mind. So it's going to be on this line because this is the 60 line. And it's going to be, what did I say, 44.1. So you can match it up. I'm not going to use a ruler. Bam. So on and so forth. You know the next one's going to be in this line and this line because it's going 20 meters per second. So let's do the next one. Displacement of y equals 1/2 9.8 times second number 4 squared. We know 4 squared is 16. So calculate that. It should be, I'm going to do that because my key is weird and I can't do it in my head. So I already know 1/2 times 9.8 is 4.9, right? So 4.9 times times 4 squared, which is 16. 16 equals 78.4. Awesome. So that's going to be about here, actually. Bam. 78.4. You know yours is going to be about the same, so we're going to put it about here. And there you go. 78.4, 78.4, 78.4. And then the last one is displacement y equals 1/2, 9.8. And then 5 squared. 5 squared is 25. So 25 times 4.9 is 122.5. So we'll say that's about here, which means this last one is going to be about here, right? 122.5, 122.5. Okay. I'm going to finish this page and then I'm going to recap because I realize some of this still might be a little bit confusing. Number 3, which of these balls strike the ground? These two balls strike the ground first. Well, ignoring air resistance, and if we keep all things equal, maybe they drop it and fire at the same exact time. They strike the ground at the same time. So you can say same, you can say tie, whatever you want to say. Let's look at number 4. It's kind of hard to see, but it's okay. I'll read it. Compare the two diagrams, the vertical freefall motion on the left and the two-dimensional freefall motion on the right. In other words, this is vertical, actually just down, only up and only down, whereas this one is two-dimensional, meaning it goes to the right and also goes down, right? So 1, 2, and this is just one-dimensional, just going down. Describe the effect on an object's horizontal motion. Describe the effect on an object's horizontal motion upon the object's vertical motion. In other words, does one affect the other? If you fire a bazooka and I drop a penny, does that bazooka firing, that forward momentum, affect how long it takes to hit the ground? The answer is no. They are completely independent of one another. So however you want to word that. So, as a recap, let me tell you why I just did this side of this whole big formula that we talked about, and then this I just did this, right? So if we talk about displacement of y equals the initial velocity times time plus 1/2 acceleration of y, because we do y since we're displacement of y, times time squared. When we're dealing with the displacement of y, the initial velocity, which is the initial firing, is how fast does it start going down, up or down? Well, the answer is its initial velocity is 0. So that's why displacement of y equals 0 times, let's say we're dealing with second number 3, times 3 plus 1/2, 9.8 because it's y acceleration, times 3 squared. So in this case, 0 times 3 is 0. So this whole side we don't need. So essentially we're just doing displacement of y equals 1/2 times 9.8 times 3 squared. That's why we just did this side, because we didn't need the other side. Now, by contrast, if I'm dealing with x, so I'm firing it, and they tell me I'm firing at 20 meters per second. Displacement of x equals my initial velocity. Well, they told me 20 meters per second. So 20 times, it's been 3 seconds, plus 1/2. There is no acceleration of x times, what did I say, 3 squared. So this is 1/2 times 0, because there's no acceleration. It just gets fired at 20 meters per second. That's not acceleration. That's an initial horizontal speed. It's bam, it's going 20 meters per second. It doesn't accelerate to that, right? So in that case, this whole side is times 0, so it's gone. So that's why, I meant to do x here. There we go. That's why our displacement of x formula looks like this. 20 times your time, which in this case we said is 3. So that's why we automatically zero out one side. Okay? So hopefully that makes it a little less confusing. ask me if you guys got any questions, but that is your intro to essentially what you're going to do for the remainder of this unit. Super easy once you get rolling. The questions do take a little bit of time, but I promise you, every question you do is going to shave off like 30 seconds. And pretty soon you're just going to be blowing through these. All right. Good job, guys. If you guys got any questions, let me know.